This lab where we talk about how we can apply these hash functions in Python code. So I will be writing some code now, and let's try to dig deeper into this this way of creating different kind of digests. And I have some tutorials here, and I have this hash lib. So first of all, let's try to generate a file where we have the hash lib. So you just write from hashlib import Blake to B. That's assuming an algorithm. I think you can also import AES, and then 2.5, which is used for disk encryption, and you can SHA-1 if I'm not totally mistaken. So let's just try to write a message or something we can hash. So I'll just write a message saying that hello world, and then I will go into the documentation here and then just see here, okay, they say message B, some message, and I actually don't have the explanation why you write B. Sometimes it's something with the encryption here. So let's try to say then calculate the first hash with a random salt. So in hashing, and especially when we try to store passwords, we use hash functions as talked about in the other videos about hashing that we can see here. We'll use them to obfuscate the password, and we'll use a salt value that will somehow enhance the security level of this salt that is unique in some way. So we have like two you add you have the password, which is hashed, and then you also add a salt from the user or some when you store this password. So you have like two parts of security that will enhance the security. We could look here at CyberChef. Let's CyberChef. I think it's this one. Yeah. So this page very, very nicely explains how and this can be used publicly. So if we go into hashing here, let's find some hash here, hashing, and then this is not secure, and even though it says secure hash, this has been broken there. So these are more secure than these are still used, and let's see here. So let's try to let's use this Blake to be here. So I'll try to see what it does. So we input hello world, and then we should cook it, bake it. So it will throw our hello world. Okay, so let's try to throw in this, and then we get this. So since we have hash values, or these hash functions, they will generate the same length here for output. So if I write hello world, it will just still be the same output. If we increase the or decrease the size, it will be the size of the amount of bits here. So it will differ in the size here. We can also use base 64. We can use raw. And we can use different kind of very useful utility here. So let's try to add a key. So hey, so you see here, you get a key, and how do we see the key? Let's try to go here and let's say salt. Okay, so we get some more security. So let's try to look at some salting here. Let's try to go back to the example we just had here. So let's try to follow this. So we'll write a message, and then we generate a salt here. So let's just copy paste this. So salt 1, we take the something from the OS random. I'm actually not sure what this is, and then we use this salt size function from the Blake to B. Let's just move this, and then we will also be able to we'll take some H1 here. So that's the hex function 1. I must assume the hex the hash one. So it will take the hash one will be the Blake to B, and then it will take the salt and then set it as the salt for this function input, and then it will generate a hash value. So let's try to do this. And meanwhile we do this, we will just print this h1, and we will try to print ms message, and let's just take this, oh sorry, and then just move up here. And then we will print the salt 1. Okay, so, and then the message. So as we see here, we can see that the salt, which is generated, has nothing to do with the actual message that we're writing. So this one is just something random from the OS. So that's another security parameter of hash functions, a way of using hash functions. Let's just try to see Wikipedia here. Wikipedia, salting hash. Salt here. So in cryptography. So let's say here in cryptography, salt is a random data fed as an additional input to one-way function that hashes the data, a password or phrase. Salting helps defend against attacks that use pre-computed tables, rainbow tables, by vastly growing the size of table needed for a successful attack. So it's very smart. So what? And let's just try. It helps protect passwords occur times the database that occur multiple times in database as new salt is for each password. Additional salting does not place any burden on users. Typically, a unique salt is randomly generated for each password. The salt and the password or its version after the key stretching are concatenated and fed to a cryptography hash function, and the output value hash value is then stored with the salt in a database. The salt does not need to be encrypted because knowing the salt would not help the attacker. Salting is broadly used in cybersecurity, from Unix credentials to internet security. And here we see how it's stored. We see that the we have the user one, we have a string to be hashed, password 123, and the hash value. And then we see the salt value here, which is a string to be hashed, so this plus the salt, and then it will be this one. So let's just go back here, and then let's just say the CyberChef, or no, not the CyberChef, the Python here. So what we have the salt, we have the for the salt here, we have the value here for the salt, and then we have then we update the message here, so we add the message. So let's print plus hash. We just raw salt. Then we have the okay, and then we will try to see calculate the second hash with a different random salt. So we take with another salt, we'll calculate the hash. Okay. The first hash, calculate the first hash with a random salt. Calculate the second hash with a random salt. So it's just for showcasing that we have different kind of salts, different kind of passwords. So salt 1 print salt 2. Let me set that. Update it, and then we update it here. Oh, print. And then we see the digester different, so not equals here. Oh, let's just see message. String must be encoded before hashing. Okay, so I think we did something wrong here. Update. I think we updated the wrong one. Let's just see. Update MSG. I think I should add the B here. Okay, so that's why it did. So that's, I think it's some kind of encoding here. Yeah, so it encodes it. So we get this value here. From this is the salt, and then we have the hashed salt. So why? I think I'm just getting the type here. So let's just, and then they are true. They are different. I just, okay. So yeah. So I'm not printing out the actual result. I think we have some kind of toString method or something. But in essence, we see that we are able to generate some salts and for these messages. So this is a very useful use case for hash functions, is when we store them in databases that we generate this salt. So please feel free to like, subscribe, and comment. Please comment if you think something could be improved. I very much, and give me some feedback. And then if you want any more subjects covered, and send me some links that you think I should present to you. Thank you for watching. See you soon.